Hello good people, I would like to talk about the Markovnikov addition. Markovnikov addition is the addition of a hydrogen halide, HX, across a double bond. Vladimir Markovnikov, a Russian scientist, noticed that whenever we do this reaction, the halogen, so the X, of the hydrogen halide will add to the more substituted carbon of the double bond. Another way to look at it is to say that the hydrogen of the hydrogen halide will go to the carbon that already has a hydrogen attached to it. This is why some people refer to this reaction as the rich get richer reaction. In other words, the carbon-rich in hydrogens will get the hydrogen of the hydrogen halide. Now, why is that? In order to gain an understanding of that, we'll need to look at the mechanism of this reaction. So here we have 2-methylpropene, and it is going to react with hydrogen bromide. The 2 pi electrons of the double bond will be attracted to the hydrogen of the hydrogen bromide. Because hydrogen can only have one bond, the electrons of the hydrogen bromide bond will end up on the bromine. And so we'll end up with something like this. Carbon number 1 will have the hydrogen of the hydrogen bromide attached to it, and carbon number 2, having lost an electron, will now carry a positive charge. What about the bromine? Well, the bromine has gained the electrons of the hydrogen bromide bond, and as a result, this bromine is now a bromide, an anion that carries a negative charge. As you might expect, a negative and positive will attract. So 2 electrons of the bromide will be attracted to the carbocation over here. And our product will be this compound down here. So the hydrogen of the hydrogen bromide is on carbon 1, and the bromide of the hydrogen bromide is on carbon number 2. At this stage you might ask, why is it that this happens? Or why is it that in the first step the hydrogen does not end up on carbon number 2? Well, let's look at that situation. So down here, I have now placed the hydrogen on carbon number 2. As a result, carbon number 1 has lost an electron and it now carries a positive charge. So once again, we have a carbocation. What is the difference between this carbocation here and this carbocation over here? Well, the one up here is a tertiary carbocation. So the carbon carrying the positive charge is bonded to 3 other carbons. Down here, this is a primary carbocation. The carbon carrying the positive charge is bonded to another carbon. As it so happens, tertiary carbocations are more stable. Or you could say that the primary carbocation is less stable. The reaction pathway will tend towards the creation of a more stable carbocation, in other words, the tertiary carbocation, which means that the halogen will end up on the more substituted carbon and the hydrogen will end up on the other carbon of the double bond. That is all for now, and I will see you on the flip side.